We'll start in about 1 minute. Oops. It's finally 10 o'clock. We'll start today in section 7.1, integration by parts. So as you might already know from Calculus 1, every derivative formula corresponds to some integration formula. And the integration by parts formula corresponds to the product rule for differentiation. So we recall the product rule for differentiation. If capital P of x is equal to f of x times g of x, so we have a product of two functions, then the derivative of capital P, P prime of x, we can write it as f of x times g prime of x plus g of x times f prime of x. That's one way to do it. So if we compute the indefinite integral of both sides, in other words, if the indefinite integral of p prime of x dx is capital P of x plus c, or we can write this, since we know what p prime of x is, the indefinite integral of f of x times g prime of x plus g of x times f prime of x dx. Well, that's equal to what p of x is, but p of x is the product of f of x and g of x. On the left-hand side, we have in the integrand, we have a sum of two products. So this can be written as the indefinite integral of f of x times g prime of x dx plus the indefinite integral of g of x times f prime of x dx, which is equal to f of x times g of x. And in the next step, we will have our integration by parts formula. So the integral of the product f of x times g of x, sorry, f of x times g prime of x dx, that's equal to f of x times g of x minus the integral, the indefinite integral of g of x times f prime of x dx. So this is one way to write the integration by parts formula. To really understand it, well, I think this form is nicer just to see what the formula is telling us. So I'll just expound a little bit on this formula. If we have an indefinite integral, and if the integrand is a product of two functions, then we identify one of the functions as f of x, and the other function that we're multiplying by f of x is the derivative of g, or g prime of x. So if you're looking at an indefinite integral that has a product, and if you want to use the integration by parts formula, you have to decide when you're looking at that product which one of those two functions you want to be f of x and which one you want to be g prime of x. So after you decide, well, if you know what g prime of x is, you can find the antiderivative of that to get g of x. And if you know what f of x is, you just take the derivative to find f prime of x, and then write the indefinite integral of that product as f of x times g of x minus the indefinite integral of g of x times f prime of x dx. So if this doesn't make sense to you yet, study this form, and then with practice, you'll make it work eventually. For convenience, what we do is, or what can be done, and which is commonly done, if we let u be f of x and v be g of x, then the differential du is equal to f prime of x dx. You learned about differentials in Calculus 1. So du is equal to f prime of x dx. And since we're assigning v to be equal to g of x, then the differential dv is equal to g prime of x dx. Okay, then what we'll do is we'll make substitutions into this integration by parts formula. So up here, we're going to replace f of x with u. We're going to replace g prime of x dx with dv. So the left-hand side is the indefinite integral of u times dv. On the right-hand side, f of x times g of x, that's just going to be u times v. And then from that, we subtract the indefinite integral. Well, instead of g of x, we're going to replace that with v. And instead of f prime of x dx, we're going to replace that with du. So both of these are the integration by parts formula. As I mentioned, this one down here is just done for convenience, so you don't have to write as many letters down. At least that's my theory on that. Hey, when using the integration by parts formula, a general strategy is pick u equals f of x if the derivative, f prime of x, is simpler than f of x. You'll see how that works in a few minutes. If it's not simpler, at least makes sure that it's not more complicated. And this is also provided that we can find an antiderivative for g prime of x. Let's look at some examples. So here's the first one. The indefinite integral of x times the natural log of x dx. We have a product of two functions. And so we want to think of one of those functions as a function whose derivative is a little bit easier. And we want to find the other function, or we want to assign the other function to be a function that we can easily find an antiderivative of. So you might wrestle in your mind, like, which one should I choose to be which? Well, let's just look at them. If we pick u equals x, then du is just dx, because the derivative of x with respect to x is 1. So that makes it simpler. But what's an antiderivative for the natural log of x? So what I'm considering is if I pick f of x to be x, or u to be x, that means dv is the natural log of x dx. And what's an antiderivative of the natural log of x? Well, that's not quite as obvious. Although a little bit later we will learn how to find an antiderivative of the natural log of x. So it looks as if it's going to be easier if I assign u to be the natural log of x. because we know what the derivative of the natural log of x is. So what is it? If u is equal to the natural log of x, what's the differential du equal to? Yeah, 1 over x dx. So the derivative of the natural log of x is 1 over x, but then we also attach the differential dx to that. And so that means our dv is x times dx, or just x dx. And an antiderivative of x, that's pretty easy. It's 1/2 x to the second. Okay, I'll jot down the formula, the integration by parts formula again. So up here, if we have the integral of u dv, u times dv, that's equal to u times v minus the integral of v times du. Okay, so the indefinite integral of x times the natural log of x dx. So u times v, I have the natural log of x times 1/2 x to the second. And from that, I'm going to subtract the indefinite integral of v times du. So that's 1/2 x to the second times 1 over x dx. So we have another integral to evaluate over here. For convenience, it's not required. This is an okay way to write what u times v is. But I'm going to write it as 1/2 times x squared times the natural log of x. And then this indefinite integral, I have a factor of 1/2, so I'm just going to bring the factor of 1/2 out in front of the indefinite integral, and then simplify x squared times 1 over x, which is just x. And now we're just one step away, because the indefinite integral of x is just x to the second divided by 2. So our final result is 1/2 x to the second times the natural log of x minus 1/4 times x to the second plus c. So I skipped a step. We can look at that here. If we just isolate 1/2 times the indefinite integral of x dx, this is 1/2 times x to the second over 2 plus a constant, which is x to the second over 4. See that? See how that works? Okay, so this is our result for that one. Okay, let's move on to the next example. So if something isn't clear along the way, or if I make a mistake, throw in the towel so I'll know what to look at. Okay, so this one, the indefinite integral of e to the x times cosine of x dx. So we want to pick u to be one of those functions. We have a product of two functions. One is e to the x, the other one is cosine of x. So we want to pick u to be one of those functions and dv to be the other function with the differential dx. So how do you want to do it? let's just try something. If you're ever in doubt, just try something. If it doesn't work out, then try something else. That's part of the learning process. Okay, so I'm going to pick u to be e to the x and dv to be cosine of x dx. So du, the derivative of e to the x is just e to the x. So du is e to the x dx. And if dv equals cosine of x dx, then v is just sine of x. Okay, so we write this is equal to u times v, or e to the x times sine of x, minus the indefinite integral of v times du, or sine of x times e to the x dx. But I'll just write it as the indefinite integral of e to the x times sine of x dx. Now we have to evaluate this indefinite integral, the integral of e to the x sine of x dx. Okay, what we're going to do next is a little detail that is sort of important for you to catch. To evaluate this indefinite integral, we're going to have to use integration by parts again. So when that happens, in this case, we want to make sure that we pick u to be the same function that we picked the first time. If you switch them, it's not that what you get will be incorrect. It's just that it will leave you where you started with, and so you'll have to start over again. Okay, so in the first case, I picked u to be e to the x. Let's look at this in isolation over here. Just treat it as its own entity for right now. So the indefinite integral of e to the x sine of x dx. So we pick u to be e to the x and pick dv to be sine of x dx. And the differential du is e to the x dx. And what is v? If dv is sine of x dx, what's v? In other words, an antiderivative for sine of x?
Negative cosine of x.
Negative cosine of x, yeah. Okay, so we'll write this as being equal to u times v. So e to the x times negative cosine of x. So I'll write it as negative e to the x cosine of x. And then we're going to subtract the integral of v du. So v du is negative cosine of x times e to the x dx. But I'll write it as negative e to the x cosine of x dx. So let's do a little bit of arithmetic here. I'll write it down here. This is equal to negative e to the x cosine of x. And we're subtracting a negative, so this will be plus the indefinite integral of e to the x cosine of x dx. So this is what we get for this indefinite integral. So let's put it all together. The integral that we started with, and you try to make sure you can see it. So we started with this, the indefinite integral of e to the x cosine of x dx. And that's equal to e to the x times sine of x. But then we're going to subtract this quantity. So you have to make sure you're careful with the negatives and the subtractions. So we're subtracting negative e to the x cosine of x, which is equivalent to adding e to the x cosine of x. And we're also subtracting the indefinite integral of e to the x cosine of x dx. Okay, what should we do now?
Add the differential on the right side to the left.
Yeah, notice that we have an indefinite integral of e to the x cosine of x dx, which is identical to what we began with. So if we add the indefinite integral of e to the x cosine of x dx to both sides, we're going to get 2 times the indefinite integral of e to the x times cosine of x dx on the left-hand side. And on the right-hand side, we get e to the x times sine of x plus e to the x times cosine of x. And now we just divide both sides by 2 to find a formula for the indefinite integral of e to the x times cosine of x dx. Okay, so our final result is the indefinite integral of e to the x cosine of x dx. I'll just put all of this over 2 e to the x sine of x plus e to the x cosine of x, all divided by 2. And then we should put plus a constant. Okay, so this is sort of a run-of-the-mill type of indefinite integral involving integration by parts, where you use integration by parts twice and then look for something identical with the original indefinite integral. Okay, the next page. Find the indefinite integral of the natural log of x dx. Does it look like we have a product of 2 functions? But we really do, because the constant 1, if f of x equals 1, that's a function. So we really do have a product 1 times the natural log of x. Or you could think of this as the indefinite integral of the natural log of x times 1 times dx. And if we use integration by parts, then what should I assign u to be equal to? How much? Natural log of x? Yeah. So let's assign u to be the natural log of x, and dv to be equal to dx. Okay, I'll do half of it. If dv equals dx, then v equals x. And you do the other half. If u equals the natural log of x, well, we've already seen this today. What's du? It's 1 over x dx. All right, so the indefinite integral of the natural log of x dx equals u times v, the natural log of x times x. I'm going to write it as x times the natural log of x. And then minus the indefinite integral of v times du. So x times 1 over x dx. So x times the natural log of x minus the indefinite integral of dx. So now we're just one step away from the final result. So the indefinite integral of the natural log of x dx equals x times the natural log of x minus x plus a constant. So now we have a derivative formula, an antiderivative formula or an integral formula for the natural log of x. You can memorize it, or you can just remember how to derive it by using integration by parts. So this is one of those that I always flub up if I try to remember it, so I just derive it on the spot if I have to. Okay, next one. Here we have a definite integral of x times the hyperbolic cosine of x dx from 0 to 1. So x times hyperbolic cosine of x dx. So pick one of those. We have a product, clearly a product of two functions. Pick one of them to be u, and then pick dv to be the other function with the differential dx. If I pick x dx to be dv, then v is more complicated than what I started with. So I probably don't want to do that. So I'm going to pick u to be x, and du is dx. And that leaves us with dv equals hyperbolic cosine of x dx. And what's an antiderivative for hyperbolic cosine of x? Have you encountered hyperbolic cosine of x and hyperbolic sine of x? It probably seems more mysterious than it really is. Hyperbolic sine of x is just e to the x minus e to the negative x divided by 2. And hyperbolic cosine of x is e to the x plus e to the negative x divided by 2. And we know how to find derivatives of e to the x and e to the negative x. And it's pretty easy to show that the derivative of hyperbolic sine of x is hyperbolic cosine of x. And the derivative of hyperbolic cosine of x is hyperbolic sine of x. So it's different from regular sine and cosine. Remember, the derivative of cosine of x is negative sine of x. But that doesn't happen here. The derivative of hyperbolic cosine of x is just hyperbolic sine of x. You can verify that by using those definitions. Okay, so an antiderivative of hyperbolic cosine of x is just hyperbolic sine of x. Okay, so u times v is x times hyperbolic sine of x. We're going to evaluate that between x equals 0 and x equals 1. And then minus the definite integral from 0 to 1 of v times du, so hyperbolic sine of x dx. We're just a couple of steps away. So x times hyperbolic sine of x from 0 to 1 minus hyperbolic cosine of x from 0 to 1. So we evaluate those. At 1, we get 1 times hyperbolic sine of 1. And then minus 0 times hyperbolic sine of 0. And then minus hyperbolic cosine of 1. And then minus minus or plus hyperbolic cosine of 0. So let's simplify a little bit more. So 1 times hyperbolic sine of 1, we'll use the definitions up here. So hyperbolic sine of 1 is e to the first minus e to the negative 1 over 2. The next term is 0. And then minus hyperbolic cosine of 1. So this is minus e to the first plus e to the negative 1 over 2. And then hyperbolic cosine of 0. That's e to the 0 plus e to the negative 0 divided by 2. Let's just take it a little bit further. We have common denominators. They all have a denominator of 2. So we have e minus e to the negative 1, and then minus e minus e to the negative 1, and then plus e to the 0 plus e to the 0 is 1 plus 1 or 2. So we get a cancellation, and we get 2 minus 2e to the negative 1 over 2, or 1 minus e to the negative 1. This is getting ridiculous, but that's all right. 1 minus 1 over e, or e minus 1 over e. You wouldn't have to go to all that much trouble if you ever have this on a test. Okay, well, that's a fairly small small set of examples of integration by parts. Make sure that you practice as much as is needed for you to master it. The problems I assign for practice from the textbook might not be enough. If you need more practice, then do more problems. We're going to review one of our integration formulas called the substitution rule from Calculus 1. So in the textbook, section 5.5 is the substitution rule. This is the integration formula that corresponds to the chain rule differentiation formula. So if u equals g of x is a differentiable function whose range is an interval I and f is a continuous function on I, then the indefinite integral of f of g of x times g prime of x dx is equal to the indefinite integral of f of u du. Okay, so you recognize this integrand? If you were just looking at that integrand, what is that? So what is f of g of x times g prime of x? It's the derivative of f of g of x. Yeah. So the answer derivative of f of g of x by the chain rule, if you remember. So that's an important differentiation rule to review. So we'll do this problem. This is a review problem of involving the substitution rule. So the indefinite integral of x divided by the square root of 1 minus x squared dx. At first glance, that might look sort of intimidating, but if you've used the substitution rule quite a bit, then it might just jump out at you what needs to be done. Okay, so here's what we can do. Let's assign u to be 1 minus x squared. And so the differential du is equal to negative 2x dx. So in our indefinite integral, we see x dx, x times dx. So that leads us to solving this for x times dx. So if we just divide both sides by negative 2, or we can write it as negative 1/2 du equals x times dx. Then we can make substitutions into this indefinite integral. I'm going to replace x times dx with negative 1/2 du. So first I'll just write 1 over the square root of u. And then x times dx is, negative 1/2 du. Well, a more convenient way to write this is to bring the factor negative 1/2 out front. So it's negative 1/2 times the indefinite integral of 1 over the square root of u du. But I'm going to replace 1 over the square root of u with u to the negative 1/2 and then du. Okay, are we all up to speed so far? We know how to find an antiderivative of u to the negative 1/2. So we have negative 1/2 times u to the negative 1/2 plus 1 divided by negative 1/2 plus 1. And so we get negative 1/2 times u to the 1/2 divided by 1/2. And this simplifies to negative square root of u plus a constant. And then we want to replace u with 1 minus x squared again. And so our result is the indefinite integral of x over the square root of 1 minus x squared dx equals the negative of the square root of 1 minus x squared plus a constant. If you're ever in doubt about the indefinite integral that you came up with, how can you verify that it's correct or not? So if I assign capital F of x to be just negative square root of 1 minus x squared, and then find the derivative, if this is the correct antiderivative, then the derivative is equal to that integrand. So does everyone remember how to find the derivative of negative square root of 1 minus x squared? So it involves the chain rule again. I can do it if you want, or, well, let me know if you want to go through that. Let's look at the next problem. The indefinite integral of inverse sine of x dx. Okay, so here we're back to integration, integrating by parts. So integrate by parts. So if we pick u to be inverse sine of x and dB to be equal to dx, so I always want to do my fair share, so I'll do half of this. If dB equals dx, then b equals x. So you do the other half. If u is equal to inverse sine of x, what's du? Oh, there are a couple of messages online that want me to compute the derivative up here. So we'll do that after we finish this one. Okay, but at the moment, we're trying to find the derivative of u equals inverse sine of x with respect to x. Okay, so this is what we can do. Since u equals inverse sine of x, then if we take the sine of both sides, we get sine of u equals x, right? If I take the sine of both sides, the sine of inverse sine of x is just x. U is a function of x, so we're going to differentiate both sides with respect to x, but with the understanding that u itself is a function of x. So we're going to use the chain rule. The derivative of the outside function, the derivative of sine of u is cosine of u. Then we multiply that by the derivative of u, that's the inside function, so du dx. we differentiate the right-hand side with respect to x, which is just 1. And so du dx is 1 over cosine of u. 1 over cosine of u is just secant of u. We want to express secant of u in terms of x. And we have everything we need in order to do that. Since u is equal to inverse sine of x, what does that mean? That means that u is the angle whose sine is x. So we can use right triangle trigonometry to help us out. This equation right here gives us the same information. If we have an angle u, the sine of u is x. Sine of u is opposite over hypotenuse, so x over 1 is what we write down for the opposite side and the hypotenuse, right? And then using right triangle, well, using the Pythagorean theorem, the adjacent side is the square root of 1 minus x squared. And we want to know what secant of u is from this right triangle. So secant of u, well, that's the reciprocal of cosine of u. So it's 1 over the square root of 1 minus x squared. Hey, so let's go back to the rest of this integration by parts. So u times v is, so I'll write down the original inverse sine of x dx. U times v, I'll write it as x times inverse sine of x. And then minus the integral of v du. Yeah, so since du dx is secant of u, or du is secant of u, which is 1 over the square root of 1 minus x squared, times, so what am I missing? Oh yeah. So this is the integral of v du. So v is x and du is 1 over the square root of 1 minus x squared. So this is minus the indefinite integral of x over the square root of 1 minus x squared dx. Okay, this is the same indefinite integral that we computed up there. So this part is just negative square root of 1 minus x squared. Okay, so we're down to the last minute, but if I interpret the messages correctly, there was a question about how to find the derivative of negative square root of 1 minus x squared. So you can think of, I'll write it on another piece of paper. So if f of x is negative square root of 1 minus x squared, you can think of that as the negative of the quantity 1 minus x squared to the 1/2. And then f prime of x, using the chain rule, is negative 1/2 times 1 minus x squared to the negative 1/2 times the derivative of 1 minus x squared, which is negative 2x. And negative 1/2 times negative 2x is x. And 1 minus x squared to the negative 1/2 is the same as dividing by the square root of 1 minus x squared. Okay, so that's all we have time for today. If there's anything else you want me to answer, I do have an office hour starting in 10 minutes, or you can send me an email if you want clarification on anything. Before you leave, sign in for attendance. Type in your first name followed by your last initial. So Josh Anderson, Liam Andrus, Dakota Park, Brecken Codwin, Haley Cochran, Jason Colvin, Nicholas Davlin, Heidi Funnel, Sarah Gonzalez, Caleb Holt, Tyler Kelly, Jacob Knight, Jacob Coons, Wesley Lemon, Audrey Mills, Caleb Patterson, Charles, Natalie James, Cole Wright. Did I get everyone's name? Okay, thanks.
So I'm on the track team. Oh, sorry. I'm on the track team, so I might miss a couple
you don't
class
have a
periods.
textbook?
Yeah. Oh, well, I might miss a couple of class periods.
Oh, you might miss a couple.
Yeah. So can
This
I give you? No, not this week. But can I bring my schedule to you? Like tomorrow?
If you remind me a few days ahead of time,
Okay.
like the week before or something like that,
Okay.
that should be good enough.
That works.
If you send me an email now, I might forget it.
Okay. That sounds good. Thank you.
Yeah.